7.3 talks about double angles, half angles, and product to sum identities. So we're going to focus on the double angles more than anything. Half angles is not something we're going to cover for our class. And product to sum, I will mention those, but those rarely come up, and we're not going to focus on them as well. We're focusing on the double angles more than anything. So, if I want to know what the sine of twice an angle is, I would write that as the sine of theta plus theta. And I know that's sine of the first cosine of the second plus sine of the second cosine of the first. And it turns out to be the same thing. One of those plus one of those is two of those. So the sine of 2 theta is 2 times the sine of theta cosine of theta. I want to do the same thing to the cosine. The cosine of 2 theta is the cosine of theta plus theta. That turns out to be, cosine says cosine of the first, cosine of the second, but they're the same, minus sine of the first, sine of the second. So that turns out to be the cosine squared of theta minus sine squared of theta, and it's right there. Somebody might look at this and say, wait a minute, can't I say that's the cosine squared of theta minus, instead of sine squared, can't I say that's 1 minus the cosine squared of theta? So that's the cosine squared of theta minus 1 plus the cosine squared of theta. And that would be twice the cosine squared of theta minus 1, which is right there. Somebody might say, well, wait a minute, why did you get rid of a sine? Let's leave the sine. Let's get rid of the cosine. The cosine squared is 1 minus the sine squared of theta. And if you combine those, so a cosine of 2 theta consists of 3 identities, and of course the tangent of 2 theta is the tangent of theta plus theta, that is the tangent of the first plus tangent of the second divided by 1 minus tangent of the first tangent of the second. Tan plus tan is twice the tan of theta over 1 minus tan squared of theta, and that's this identity. Now comes the crucial part. If I take, and everything comes from cosine, if I take this identity, if I take the cosine of 2 theta, which equals twice the cosine squared of theta minus 1, if I solve for cosine squared, I would add 1 to both sides. And I would divide by 2 both sides. I'll get the cosine squared of theta to equal 1 plus the cosine of 2 theta divided by 2. That is this identity. And if I take this identity, and I would say the cosine of 2 theta equals 1 minus twice the sine squared of theta. If I swap those, twice the sine squared of theta equal 1 minus the cosine of 2 theta. And if I divide by 2, I get the sine squared to equal 1 minus the cosine of 2 theta divided by 2. That would be this identity. The tangents I will provide, but the sine and cosine you need to memorize. So here we are. We're going to focus on those more than anything else in this section. And whatever comes up on the homework, you're responsible to know. Find the cosine of 2 theta. Find the sine of 2x, cosine of 2x, and tan of 2x. Given tan of x equals 3 and cosine of x is less than 0. What I need is the triangle. If tangent is positive, that's going to happen in quadrant 1 or 4. Cosine is negative in 1 or 3. Cosine is negative in quadrant 1, 2, and 3. So the triangle must be in quadrant 3. This is over 1. Tangent is the opposite, there's theta, over the adjacent. And I know both of those are negative. And the hypotenuse would be the square root of 10. If I want to know what the sine of 2x is, that is, I'm so stuck on theta, the book goes back and forth. That is twice the sine of x cosine of x. That is twice. The sine is negative 3 over radical 10. And the cosine is negative 1 over radical 10. This is good enough for my test. For the back of the book. There it is. If I look for the cosine of 2 theta, the cosine of 2x, you have 3 options. Any one of them will do. If you decided to go by the first, you want to say this is the cosine squared of x minus sine squared of x. That's fine. You could do that. You could do twice cosine squared of x minus 1, or 1 minus twice sine squared of x. The answer is the same. Cosine is the adjacent over the hypotenuse, and sine is the opposite over the hypotenuse. Again, this is a fine answer on a test. You want to match the back of the book. There it is. And if you want to find the tangent of 2x, that is twice the tangent of x divided by 1 minus the tangent squared of x. I provide that on your test. Tangent is the opposite over the, so it's 3 over 1. On a test, that's sufficient. For the homework, you want to clean that up, and you will get 6 over 1 minus 9, negative 8. You'll get negative 3. And there it is. If I look at the next problem, same deal. I want to sketch the triangle. That's the key to any problem. Secant is positive. Secant deals with cosine. Cosine is positive in quadrant 1 or 4. Tangent is negative in quadrant 2 and 4. My triangle is in quadrant 4. There's x. This is the hypotenuse over the adjacent. So that makes the y negative in this quadrant, and it's square root of 25 minus 1 square root of 24. Or simply 2 radical 6. Either way. So if I want to find the sine of 2x, well, that is twice the sine of x cosine of x. That is twice. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. On a test, you're done. For the homework, that would be the answer in the back of the book. Cosine of 2x, that would be, I'm going to use in this case twice the cosine squared of x minus 1. Again, you could use any of the 3 identity that will do the job. Cosine is the adjacent over the hypotenuse. On a test, that's sufficient. For the homework, 2 over 25 minus 1. That is 2 minus 25, negative 23 over 25. And as for the tangent, the tangent of 2x is twice the tangent of x over 1 minus tangent of x squared. The tangent of x is the opposite over the adjacent, negative square root of 24, or negative 2 radical 6 over 1 minus negative the square root of 24 squared. Again, this is sufficient for the test. For the homework, that's going to equal negative 4 radical 6 over 1 minus 24. That's going to be negative 4 radical 6 over negative 23. That's going to be positive 4 radical 6 over 23. And there it is. That's pretty much all there is to those. That's one portion. Another portion is to reduce. This is the stuff you need for calculus. Reduce. Well, we know what this is. This is 1, and it's right there in case you're missing it. 1 minus the cosine. And how does that correlate? You double the angle. That's all there is to it. Whatever that angle is, you double. So this is 1 minus the cosine of twice that angle divided by 2. You're done. And if I wanted to find this, this is 1 plus the cosine of twice that angle divided by 2. So the goal here, if you read the directions, is to make that a power of 1. Now, what if I'm looking at C? I would say two ways of doing this. Either I'm going to say this is the sine squared of x times the sine squared of x, or the sine squared of x quantity squared. This is 1 minus the cosine of double that angle divided by 2. And this is 1 minus the cosine of double that angle divided by 2. So, I'll take the 1/4 out, or make it all over 4, whatever you like. If I FOIL the top, that's 1 minus twice the cosine of 2x plus the cosine squared of 2x. Everything is matching except for one value you're not allowed to have. So the directions, if you read the directions properly, you'll notice it says write them to the power of 1. I need to reduce this one more time. Cosine squared is 1 plus the cosine of double the angle. If my angle happened to be 2x, what would be double the angle? Isn't that 4x? This is a complex fraction. Those never go away. LCD is a 2. So you multiply this by 2 top and bottom, 2 top and bottom, and 2 top and bottom, and you read the top, 2 minus 4 the cosine of 2x plus 1 plus the cosine of 4x all over 8, and one more step. 2 plus 1 is 3 minus 4 the cosine of 2x plus the cosine of 4x all over 8 would be my final answer, in which the power on every cosine or sine is simply a 1. And if I came across this part, D, well, the same deal. This is 1 minus the cosine of 2x. You double the angle every time you reduce power. 1 plus the cosine of 2x divided by 2. This is all over 4. If I FOIL the top, I'll get the first squared minus the second squared. I'm not done because I need them all to be in terms of the first power of cosine, and that's not it. So this is all over 4, 1 minus. If I reduce this, that is a fraction. That's 1 plus the cosine of double that angle divided by 2. A complex fraction again. This is over 1, this is over 1. Multiply by 2 top and bottom. Ignore the denominators. That will be 2 minus, I'll just push that, let me give it some space. That will be 2 minus 1, oops, distribute the negative n, minus the cosine of 4x divided by 8. And if I combine like terms, that is 1 minus the cosine of 4x all over 8. And that would be my final answer. See if I should fit this in a separate video. Let me see how many problems I still have to go. I think we could finish this here. So, write the given expression in terms of x. Okay, we need to clean this up. Do remember, this is an angle. I call this angle theta. I'm really looking for the sine of 2 times that angle theta. So theta can only be the inverse correct function. The 2 can be part of it. I know what this is. This is twice the sine of theta cosine of theta. If you tell me what the sine is, and you tell me what the cosine is, I'm done. How am I going to figure that out? I'm going to go on the side and say, I let theta equal the inverse cosine of x. That means cosine of theta equals x. I am in quadrant 1. Why is that? Because if it's a variable, unless they tell you otherwise, we assume it's positive. And this is the adjacent over the hypotenuse. Y in this quadrant is positive, so that is 1 minus x squared. And what do I need out of that? And how do I get 1 minus x squared? Call this L. 1 squared equals x squared plus L squared. 1 minus x squared equal L squared. When you square root, it's plus or minus. In quadrant 1, it's positive the square root of 1 minus x squared. The sine is the opposite over the hypotenuse. And the cosine is the adjacent over the hypotenuse. You want to simplify it for the back of the book, you can. That's what the back of the book will have. Now keep in mind, you have to show me work on this on the exam. The reason I'm mentioning this, 2 students didn't show as much work and they got away with it somewhat on the first exam. On the second exam, I insist on you showing me the work. This is an angle. That's theta. So I'm looking for the cosine of twice theta. Here I have 3 options. Any one of them will do. Either way, I need the cosine or the sine for this to work. So I'm going to go on the side and say, if I let theta equal the inverse tangent of x, that means tan of theta equals x over 1. My triangle is in quadrant 1. We know that. And the opposite over the adjacent, that makes this the square root of 1 plus x squared. If I decided to go with, let's say, cosine squared of theta minus sine squared of theta, you could. Any of the 3 identities would do. Cosine is the adjacent over the hypotenuse. And sine is the opposite over the hypotenuse. On a test, I will accept that. For the homework, 1 over 1 plus x squared minus x squared over 1 plus x squared. That is 1 minus x squared over 1 plus x squared. That would be the answer in the back of the book. Verify the identities. Here, not much leeway. So if I look at this, I notice the angles are not the same, so I know what to do. I need to get out of 6x a 3x. So wouldn't you say 2 times 3x will give me the 6x? The cosine of twice an angle, isn't that 2 times the sine of that angle, the cosine of that angle? And there it is, done. Even though you might think identities are tougher in this section, not really. especially for a sine. I look at part B and I'm thinking the top has one of three conditions, but the denominator is fixed. The denominator is 2 times the sine of x cosine of x, nothing else. I have to figure out the top. Should I use cosine squared minus sine squared? Well, that wouldn't play well with those. Should I use 1 minus sine squared? Maybe that'll work. Or twice cosine squared of x minus 1? That might work. Either or. So if I decided to go for 1 minus twice the sine squared of x, okay, what would that be? That's twice the sine of x cosine of x. This will be 1 minus 1 plus twice the sine squared of x. Those cancel out. I am left with twice the sine of x over twice the sine of x cosine of x squared. And wouldn't those cancel out? Wouldn't this cancel one of those? And what's sine over cosine? Isn't that tangent of x? And there it is. I'm done. And that's pretty much it for this section.